And I mean that literally. How in the world do you fine-tune a piece of machinery that is the size of a small apartment building? We are so far beyond a car engine here, this is a mechanical titan.
Well, you might be surprised to learn that the answer starts with something relatively small. To tune this giant, you have to focus on one single critical part, the fuel pump. Think of it as the heart of this massive beast, and getting its rhythm, its timing just right, well, that changes everything.
And what a beast we're talking about. We're diving into the world of manned B&W two-stroke engines. These are colossal power plants that are, and this is no exaggeration, the size of a multi-story building. We're talking about pistons so big you could comfortably stand inside one.
And these aren't just for show. They're absolutely essential. These engines are the unseen, unsung heroes of our global economy. They're what push the world's largest container ships across oceans. In some places, they even generate the electricity for entire cities. They are, in a very real way, the pulse of the modern world.
So, here's where it gets really interesting. Inside that gigantic engine, the absolute smallest adjustment can have a truly monumental impact. We're about to walk through a procedure where perfect timing isn't just a nice-to-have, it is a non-negotiable for power, for efficiency, and for safety.
The whole operation, really, it revolves around one key idea, Pmax. The easiest way to think about it is as the engine's maximum power punch. It's that peak pressure that builds inside the cylinder, and it has to be unleashed at the absolute perfect millisecond in the piston cycle. You do that, and you get the most force possible out of every single drop of fuel.
So, how do you control that punch?
Well, it all comes down to adjusting something called the fuel cam. If you turn it one way, ahead, you increase that Pmax. You're fine-tuning it for maximum power. But if you turn it the other way, astern, you actually reduce it, which is super important when you're using different kinds of fuel or the engine is under a different load. It's a really delicate balancing act.
Okay, so how do they actually do it? This is not a case of just turning a screw with a wrench you have lying around. No, this is a full-blown precision operation. It takes methodical preparation, and it takes a very, very skilled engineer.
And before a single tool even comes out, the first step, the most important step, is always safety. The manual couldn't be clearer about this. You have to relieve all the pressure from the fuel pump and drain every drop of oil. You're dealing with incredible forces here, and skipping this step, well, that's just not an option.
Right, with the system safe and depressurized, the engineer can start to open up the machine. The inspection cover comes off, the puncture valve is taken out. It's kind of like a surgeon preparing for a delicate operation, right? Every step is deliberate, each one designed to give perfect access to the part that needs adjusting.
Now, this is really cool. Check out the tool they have to use. You can't just use any old wrench. This is a special spanner, and it has to be mounted right onto the fuel cam disc. If you look closely, you can see these little pins on it. They're designed to fit perfectly into the holes on the cam. This is custom-built, high-precision stuff.
And here we go. This brings us to the very heart of the procedure. This is the moment of adjustment, where one tiny, tiny movement is going to echo through this entire massive engine. This is where millimeters, even fractions of a millimeter, really matter.
So what the engineer does is apply hydraulic pressure. This pressure actually expands the cam just enough, we're talking microscopic levels, so it can be moved on its shaft. It has to stay pressurized for at least 5 minutes before the turn, and then it has to stay pressurized during the turn. And only then, with that pressure on, can the engineer use that special spanner to make that tiny, crucial rotation.
Okay, the turn is complete. You might think the job is almost over, but you'd be wrong. In fact, one of the most critical and, honestly, most surprising steps is about to happen, and it involves patience in a way you probably wouldn't expect.
And this quote from the manual just says it all. It literally says to wait at least 15 minutes. Why? Because the cam, this huge piece of forged metal, needs time to settle after being moved. Isn't that incredible? The materials themselves need a moment to get used to their new position. Now, this isn't the engineer taking a coffee break. This is a non-negotiable part of the process. That 15-minute wait ensures that when the hydraulic pressure is finally released, the cam grips the shaft again with the unbelievable force required, and it stays exactly where the engineer put it. It's a testament to the mind-boggling forces at play inside this machine.
After that all-important wait, the procedure is done in reverse. Everything is meticulously put back together. The pressure is released, the tools are dismounted, the covers are put back on. But the job still isn't finished until all the data is recorded.
This is how they track the engine's performance over time and prove that the adjustment actually worked.
So let's zoom all the way back out for a second. That entire painstaking process, the safety checks, the special tools, the hydraulic pressure, even just waiting, it all comes down to this. A turn of a few millimeters deep in the heart of the engine translates into saving tons and tons of fuel out on the open ocean. It means more efficiency and lower costs on a truly global scale.
It really makes you wonder, doesn't it? What other hidden, high-precision adjustments like this are happening all around us, in these massive machines we never see, that are quietly, expertly keeping our entire world